Hello, everybody. So hopefully everybody did well on their 2 weeks of AP testing. We're back. I want to finish off electricity. I know I said I want to do astronomy the last few weeks, but with just really 1 week left before June 1st, I remember June 1st is when you could turn in all your late work. I just thought we're just going to finish off electricity, what's important, and then maybe do some astronomy at the end. We'll see how it goes. But I'm going to try to finish off all the grading material wise by this week so you have time to catch up if you need to catch up. And pretty much for physics honors, everybody's doing well. As long as you do everything, everybody should get an A. We kind of left off with only like one or two B's in third quarter, so it can only go up. So as long as you train in your stuff, you'll be in good shape. Today, I want to focus on what you see when it comes to electricity. We ended 2 weeks ago talking about series versus parallel. And I want to kind of talk about how our home is kind of a combination of the two and kind of talk about the main parts that we have at home. So your home could be one of two things. It could be a home that has underground, or it could have an overhead ground. So it just really depends on the city. It also depends on when your house was made. Most homes, I think, after the 80s will probably be underground. Most homes before the 80s will be overhead. There is no advantage or disadvantage other than just the look of it. So if you have overhead, you just have a wire going into your house from around your roof area. If it's underground, you don't see anything. You might see a green box. So this would be kind of like the green box. It's this 3B, which we'll kind of look at it, which is a transformer. It'll come down, and electrical grid from overhead will come into this green box and then go into your home. But either case, you're going to have a meter on both homes. So from the home on, it's practically the same. How it gets to your home might be a little bit different, but once you get into your home, it's pretty much the same thing. So kind of overview the two things. Above ground, you're going to have a wire way up here, and I stole this from the website PPLE or peopleelectric.com. I thought I really liked the pictures. It was really simple. They have a diagram with all the different things that are perfect. So it's pretty much electricity comes in, it drops into your house, it goes into the meter, and at this meter is where it gets distributed into your circuit breaker, and then it gets distributed into your home. Your meter is where you paid for it. So the power company will either send the information through cell phone or Wi-Fi into their system, and you pay through it that way, or you have somebody walking through every house reading the meters and recording it, and then you paid for it later. If it's underground, it's very similar. It still goes into your house in a meter, and it does the same thing. So it goes from the transformer, which is right here, and it goes into your home and then into your house itself. The transformer for this one is actually up here. So that trash can looking thing, if you ever looked up there, is the transformer. So why can't I get it? There we go. This is the transformer up there. So it's either the green thing down here or a kind of like a trash can looking up there. That's where you're going to convert high voltage into 120. So once it gets into your house, it's 120 volts. It might have some clever things to up it up to 240, which we'll talk about. But pretty much it's either 120 or 240 once it gets into your home. So you could either have overground or underground, but pretty much it gets into something called your meter. And there's kind of most likely two types of meters out there. There's going to be the old-fashioned one. This is the analog, if I spell that correctly, and then you have your digital. And the digital is really cool because most likely this is either I think it's a cell phone, but it sends the information to the power company wirelessly. So the electrical meter guy never has to come to your home and read it. If you have an old-fashioned one, then somebody comes to your house and reads it every day. So one time it just freaked me out. I was taking out trash and the guy was reading our meter, and like I screamed and kind of freaked him out when I screamed. But in the past, I used to have an analog. I think 2 years ago they upgraded into a digital one, so now everything is wirelessly sent. The digital one's really cool because within like a few days I could get my readout of my power usage of that day. So usually I could look back 2 days ago and I could see exactly how much energy I used and what time I used it. I should have loaded it up on my screen, but it'll kind of break down what time is my peak. So whether it's like 4 p.m. when it gets really hot and you crank on the air, or when I plug in my cars. Usually is when I plug in my cars. I plug in my cars at 9 p.m. and you see this huge spike in kilowatts. So what is kilowatt? So a kilowatt is 1,000 watts is per hour. So what does that mean? So let's say you have, most likely the only thing in your house that's 1,000 watts is a heater, like one of those portable heaters, maybe a hair dryer, a microwave. So these are appliances by itself is about 1,000 watt usage. So that means you have your heater on for 1 full hour will equal a kilowatt hour. Or you have your hair dryer on for 1 whole hour. So that will equal a kilowatt hour. And usually you're going to have these rates. Mine is the time of use. So meaning that it's cheaper at certain times for me and more expensive at certain times. So one of these older analogs, they won't be able to do these kind of rates. And the reason why most of the electric company did upgrade in this is they want to charge you at specific times. Because now what happens, you'll notice, it doesn't really make sense, but you'll notice, hey, 8 a.m. to 4 p.m. is like the cheapest rate. And it's because California has been very aggressive in getting solar panels in. So a lot of homes are generating a lot of electricity from 8 to 4 p.m. So electricity is fairly cheap at the time because the power company doesn't have to produce it. So I probably should have talked about how electrical system works. So you have a power generator or a power station, either burning natural gas, nuclear, which is kind of all obsolete now. So most likely it's natural gas, coal, or water, or air. And these things are powering stuff. Wind turbines are conditional, so you can't control those. Water you can with a dam. Natural gas and coal you can control by burning them when you need them the most. When the sun's out, the solar panels will produce a lot of energy, so our coal plants or our power plants that are burning natural gas don't have to do anything. When we start getting into the 4 to 9 p.m., the reason why that's the most expensive is because the sun is kind of setting by then. And also that's when everybody's coming home from work and turning on their air, cooking, washing, whatever. And then at nighttime, everybody's going to bed. So that's also another place where you have cheap electricity. So that's kind of the breakdown of it. And digital could tell you when you're using it so they could charge you accordingly. So that's the first thing that your electricity will go into, which is your meter. And it's measured by kilowatts per hour. Here you can see that it's 13 cents. So most air conditionings are around, let's see, they're around 60 amps. So let me calculate it really fast. So let's say your air conditioning is 50 amps, which we'll talk about soon. So 50 times 20. So, wow, that's a lot more than I thought. So your air conditioning is like 50 amps. So if you're running it full blast all day long, most of the time it does turn off. But if you're running it for 1 straight hour, it's about 6 kilowatts. So that means if you run your air conditioning for 1 hour during the peak time, it's quite expensive, right? 6 times 40 cents, 30 cents. So you'll be paying about $2 an hour or about $1.50 an hour. So that's kind of how air conditioning or pools kind of suck up a lot of energy. Then from the meter, it goes into a circuit breaker, and this person has it nicely labeled and stuff. This is actually my circuit breaker. So if you look here, my meter's down here. Oh, sorry. If you look down here, my meter is down here, and then this is my circuit breaker up here. This is the main switch, and in the few pictures that it'll show you, but this is 200 amps. And then you have all these breakers here, and you'll notice that they're all labeled. So what's going to happen is you're going to have electricity from the ground, for me, because I have underground, go up into the meter. The meter will count how much electricity I'm using, and then it's going to go into my circuit breaker. My circuit breaker, and then feeds the rest of my house electricity. So these are all in series. So what you have is something called a circuit breaker, which is kind of a very fail-safe thing. So when you look at a circuit breaker, you'll notice that it's like a switch. And on these switches, you have these numbers. So I was talking about amperage here. So the bottom one is 200 amps. And what does this mean? Well, remember, P equals IV. Power is equal to current times voltage. Power is watts. Current is amps. And voltage is volts. For us, our home is always the same, 120. So everything else you could kind of figure out. I mean, and I do say sometimes it's 240. So you'll notice right here, this is called a two-pole circuit breaker. You'll notice that two of them are together. Here's another one, and here's another one. And you'll notice the ones that are attached are usually big items. So AC here, your dryer takes up a lot of electricity because it's burning something or heating up an element to dry your clothes. Your dishwasher, same thing. It's heating up water to dry your things. And usually it's not natural gas. So your dryer could be natural gas, but most likely your dishwasher is just pure electricity. So that's why you want to make sure that you have a double pole. Double pole usually gets you up to 240, if I can spell double correctly, 240 volts. So it gives it a little bit more power to do the task that it needs to do. So if you look here, then that means if we plug in 120 normally times 200, which is the max load on your house most likely could pull at the most 200. Let me clear my old one. 200 times 120, 24,000 watts or 24 kilowatts. So that means most of your homes are only wired to kind of draw in this amount of energy. If you draw more, what's going to happen is the circuit's going to break. It's kind of a fail-safe, because usually what happens if you're drawing too much energy, the wires get really hot. So it wants to prevent your house from burning down, because if your wires get too hot, it might catch on fire, bad things happen, or sparks happen, things like that. So these circuit breakers are there to prevent bad things from happening. So by having it here, so if your AC normally, so if you look at AC, so I kind of just Googled it, you can have big ACs or small ACs. When you look at ACs, if you click on, let's say, a specific one, it depends how big your house will depend how big your thing is going to be. But if you look at the specifics, this one is 40 amps. So normally only pours 40 amps. So if you look back at this picture, let's say my air conditioning unit is 40 amps. This one is safety is 50. So that means even if it's running at maximum capacity, it's not going to hit that 50. Only when something's wrong and it spikes above that 50, you want to make sure that circuit breaks. So what you could do at home if you really want to test your circuit breakers is plug in like 2 heaters in your room, crank them on full blast, and it should break. Your heaters, like the little portable ones that you could buy. So let's say you have, I think this is like the most typical one that you might see in your home. This one is 1500 watts. So if you do the math on that, P equals IV, power is 120, I got to mix up. Do it again. 1500 for watts, and then the voltage is 120 voltage. So if you do that division, clear my phone, 1500 watts divided by 120, it will give you 12.5 amps. So most likely if you plug in 2 heaters in your room, it should trip it. So that's why you should not plug in too many things. And the cool thing about circuit breakers, it's not what you think. So when you look at mine, you'll notice that it's broken up weird. You have kitchen, which you kind of want on your own. You have the oven, which you want on your own. More kitchen. And then you have like your bathtub. I have a bathtub that has little jets. Smoke detectors you want on your own. Fire sprinklers you want on your own. But then you'll notice that they mixed all the blood. What's it called? So here's all of them together, and I did a zoom in so you can see the amperage of it, so you can see how much it draws and what it's protecting. If you look here, you can see my handwriting, because I was trying to figure out what's going on here. They kind of put all your sockets in your rooms kind of all together. So here you can see a couple of rooms are all in one breaker. So usually when you break one, couple of rooms will go out, maybe a hallway. It just depends how they wired your home. So if you're really bored, You could plug things in and break it and go back upstairs or downstairs or in the, if you have one story, and see what works and what doesn't work. I guess technically you could prank your friends, open up their circuit breakers, turn everything off, and run away. That's why I keep mine locked. So if you look at this picture, you can see this lock, just because I'm kind of paranoid. I don't want somebody just coming in and turning it off. When it comes to like alarms, if you have those Arlos and stuff, if you turn these off, it would shut off your alarms. So what you want to be smart in is to also have something called a UPS, which is uninterrupted power supply. And you plug this in, and this will kind of give you like an hour extra worth of energy to power in your alarm system or your phone, like your internet or your whatever, your computer. So you have enough time to turn everything off before you run out of juice. Most home alarms are kind of wired into your phone as well. So that's why in the past, if you see movies when they're breaking into something, they want to cut the phone line because that's where it gets its power. Nowadays, they're a little bit more clever. You can't just like go to a circuit breaker and turn things off and your alarm won't work. They have multiple powers, or they have a battery backup, and then they have most like a cell connection that sends it up there. So you can't kind of break into somebody's home that way. But it's nice to know your circuit breakers. So what I like you to do is kind of look at your circuit breakers at home, find where it is. It's important because if you ever break it, you need to unbreak it. So let's say I plug in too many things. This thing trips. When it trips, it just flips over to the other side. The power is lost in that room. So you have to go to your circuit breaker and turn it back. And once you do, it should work unless everything's plugged in. So take that back. If you trip it, unplug everything, or unplug like the big stuff like heaters, turn it back on and turn one and off at the same time. So I do like you for your homework is to go find where it is, kind of look at it, figure out what's plugged in, what's not plugged in, and just be familiar with it. I think it's very important to know how to turn it on and or off. So that's kind of how your house is wired. These are in series because this is the switch for all the outlets. So once you turn it off, since it's in series, it's not going to go into anything in that circuit. All of them are off. Within your room or within each of these circuits, it's parallel because you don't want to plug in everything in order for it to work. You just want to have single things. So your house is both plugged in series and in parallel. In one circuit, it's in parallel, but then at the circuit breaker, they're in series. So hopefully that makes sense. Hopefully that kind of gives you a little better understanding of what's in your home and how everything works. Your car has similar things. Instead of a circuit breaker, it's called a fuse box, and you could explore that as well. All right, so have a good day and take care.